Okay. So we're recording. I'm sharing my screen. Things are good. All right. So today we will go through the long answer section of the practice test. Okay. I'll post the solutions to the short answers, but they're just quick little calculations, right? And so you can just check those solutions. There's no point for us to work through them together. But I do want to kind of hold your hand through the long answers. So that's what we're doing today. But we are going to just finish chapter 5, which is the last section with continuous compounding. Okay, so I won't do a review because it'll take up too much time. And it was just on Tuesday. So, but we did that kind of bigger example with equivalent payments, right? With compound interest problems. And what else did we do? Can't remember. Changing interest rates for continuously or for compound interest problems. So section 5.7 is on continuously compounded investments. I'll rewrite that. Oh yeah, and I also showed you how to do compound interest problems on your calculator, right? With the N interest per year, present value payment functions, and the future values, right? How to input those, and just you can check your answers and even do the work on your calculator. Usually people don't like using the calculator for the second test, but by the third test, you guys like it more. So you're welcome to use it. But so for continuously compounded investments, if you have been kind of following along on your formula sheet, right, for compound interest, last day we finished when we talked about the changing interest rate, which was the second to last formula on the formula sheet, right? And so today we're going to talk about this last one, which is the future value, is the present value times e to the power of RT. This is on your formula sheet. So that e is what lets it be continuously compounded, right? The exponential function. So continuously compounding is very hard to imagine, right? Because we've talked about, okay, it's compounded monthly or it's compounded semi-annually, right? So that's how often the interest is being compounded with the principal amount, right? But there is such a thing as just continuously compounding, right? So every fraction of a second, it's being just compounded, right? And so it feels like we should be getting a lot of interest, but what you'll actually find is that there's not a huge difference between the two, right? Whether we're compounding annually or compounding continuously. And so we're just going to outline, so where, of course, FV is the future value, we don't even really need to put that. PV, of course, is the present value. E is just the number, right? 2.17, it's an irrational number. And so R is the nominal interest rate. And T, of course, is the time in years. Right? T is always time in years. So let's do an example, example 192. So 13 years ago, you borrowed $7,500 at a rate of 2.5% compounded continuously. Right. That means that we have to use the special formula with the E in it, right? What would be the equivalent annually compounded rate at which you borrowed this money, right? So annually compounded means that we want to force it to have a frequency of 1. At which you borrowed this money. And so we're going to have to figure out, okay, we've done this before, right? Where we've got this changing interest rate. You had one of those questions on your assignment, the one you guys were working on last day, I want to say, where you've got a changing interest rate and you want to find what single rate is equivalent. We're essentially doing the same thing here, right? We're saying, okay, well, if I've got this continuously compounded rate, that's going to get me to some future value. Now I can take a step back and say, okay, well, what annually compounded rate would take 7,500 to that same future value, right? That would be an equivalent rate. Okay. And so what we're going to do is we're just going to map this out. There's only 2 time points, right? And so 13 years ago, and then here we are today. So you borrowed $7,500. That's the amount that goes underneath. And we're going to figure out what that value is today. Time goes on the arrow, right? For continuously compounding, we're only talking about t, so it's fine to just leave t in years, right? We don't have any number of compoundings. And so we're just going to put t equals 13 on here. We know that the rate is 0.025 and f is continuous. So it's always. So using the formula, right, we have the future value is the present value times e to the RT. The future value then is 7,500 times e to the power of r, which is 0.025, times t, which is 13. If we simplify 0.025 times 13, I get 0.325, so I'll start there. 7,500 times e to the 0.325. How do you do? Okay, so the e to the x button is actually in the second menu over the log button. Okay. So it's 1, 2, 3, 4th button up from the bottom left-hand corner. Sorry, the natural log, ln. Okay. And so what you're going to do is, if you have it on your calculator, you have 0.325 on your screen. I'm pretty sure. Let me just check. It's been a while. Yeah. 0.325, and then second, and then hit the LN button. Right. Should have an e to the x, right? And then hit equals. It might just do it for you, but 0.325, second ln, equals 1.384030,646. So just make sure that you get that same value, right, when you do it. So this becomes 7,500 times 1.384030,646 times 7,500. I get a future value of 10,380.22984, which in money is 10,380.23. So what we need, therefore, we need to find the annually compounded rate R that has the present value equal to 7,500, right? Same as this one. And future value equal to 10,380.23. So going back to our usual formula, right? We've got the future values PV times 1 plus I to the power of n. Okay. We're going to end up solving for I, right? Because our end goal is to solve for R, but to get there, we have to find the periodic interest rate I, and then we can find R. But because if you look at this and say, okay, I want to find R, which means I first have to find I, you could just go ahead and use the formula for I. I'm not going to do that because I already wrote that, and there's no taking it back. So, no, there is, but I think it's good to show you how it's solved for. But if you just wanted to plug into the formula for I that's on your formula sheet, that's totally fine. So, future value, we're forcing it to be 10,380.23. The present value, we're forcing it to be 7,500. And 1 plus I, we're solving for I. N, if we're compounding annually for 13 years, maybe I'll make a little note here. N is time times the frequency, which is 13 times 1, which means we have N is 13, right? You could draw a quick little timeline and map it out and figure it out, but we've got N is 13. Solving for I, right, I have to divide both sides by 7,500, so I have 10,380.23 divided by 7,500. So I get 1.384030,667 is 1 plus I to the power of 13. That means we have to take the 13th root of 1.384 blah, 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 right? Just to get rid of that power of 13. So how we show that is we do a square root, but in the little hook, you put a 13. of 1.384030667, which is 1 plus I. It's the 13th root of something to the 13. Those cancel out. Do you remember how to do these guys on your calculator? So on your calculator, you're going to do 1.384030667, and then hit the y to the x button, and then use brackets 1 divided by 13 brackets equals, maybe I'll put up above here, 1.38403667 to the power of 1 over 13. Right, that's how you take the 13th root. So if I have that and I hit this to the power of 1 divided by 13, you have to hit the equals, otherwise it'll just show you what 1 over 13 is. So hit the equals just in case. 1.025315122. So then here on this side, we get 1.025315122 is 1 plus I. Solving for I, and I like to have whatever I'm solving for on the left-hand side, so I'm going to kind of revolve them around. Then I is 1.025315122 minus 1. Otherwise, our periodic interest rate is 102.5%. That's never going to happen, right? So that's why you have to take away the 1. So you get down to a reasonable 2.5%. Right? So the periodic interest rate is 0.025315122. Okay. Okay. We wanted to solve for R, right? But I is R over F, and F is 1, right? And so to solve for R, we need I times F. R is 0.025315122 times F, which is 1. So R is 0.025315122, or 2.53%. Womp womp. Because what happened? So we had 2.5% continuously compounding. So continuously getting pressed together. Well, that's only the same as 2.53% compounded annually. So it actually doesn't make that big of a difference, right? It does because it's money, right? And so every little bit counts, but doesn't make that big of a difference. And so the continuously compounded rate of 2.5% is equivalent to the annually compounded rate of 2.53%. So very, very similar. Disappointingly similar, because continuously compounding sounds so good. Any questions about that? Practice, test, practice, test. All right. It can be on the test, yeah. It's allowed to be on the test. Not in the long answer, but maybe a short answer. Yeah. Shot to the heart. Yeah, this was just a quickie. All right. All right. Do I need to go grab the practice test, I think. Mm-hmm. Put it with you guys there. Aha. Okay, so as promised, I'll post the solutions to the short answers, but we're just going to go through the long answers, right? Because those are where most of the marks are. So approximately 20 marks worth of short answers, and then 10 marks each for the long answers, and there's 4 of them, right? So make up where you're going to focus. I also really don't want you wasting time on the short answers during the test until you've done the long answers, yeah? And then just go through and do the ones that you know, and then just kind of iterate through, right? Because I do find that a lot of people want to start from the beginning and work their way to the end, but there's more marks at the end, so you have to be strategic about it. Wait, haha. All right. Use this page break here. So practice test number 2, long answer solutions. Okay. So Rocky and Adrian, and I think you had something similar in a Moodle quiz at some point, kind of recently maybe. But so Rocky and Adrian have become real estate agents. They're selling their house and received 2 offers. Okay, so the first one is $450,000 in total with $50,000 down. So that's today, right? And then 2 payments of $200,000 after 2 and 4 years. Okay. Or $475,000 in total, but only $25,000 down today, right? And then 1 payment of $450,000 in 3 years. Okay, so assuming a 60% rate of simple interest, which offer should Rocky and Adrian choose? Justify your answer, include a timeline in your answer, and use today as the focal date. Right, so when I tell you what focal date to use, that's where you're going to draw your money to. It's to make it easier for you, right? But also you have to follow instructions. So use today as the focal date. How much more is the better offer worth? So we're going to find the value of both offers today, and then subtract the bigger one or the smaller one from the bigger one, and that's our answer. Okay, so We've got two separate offers. I'm going to do a timeline, a separate timeline for each of them. And so I'll do offer number 1. Looks like today. And then I've got an offer in 2 years, 2 years, and then in 4 years. Okay. So today, offer number 1 has 50,000 down. And so you get a raw 50,000 today. They're also going to get 200,000 after 2 years and 200,000 after 4 years. Using today as the focal date, we draw this payment. We're drawing it backwards, right? So that makes it a present value. We're pulling the arrow back. Present value 1, because I anticipate having to do more calculations, so I'm going to number them in the order that I'm going to do them. And present value 2, adding 50,000, present value 1 and present value 2, that's the total value of offer number 1 today. Okay. We've got compound, oh, sorry, haha. I tripped myself up. Assuming a 6% rate of simple interest. The only real trick with this test, right, test 2, is it's going to be on simple and compound interest, right? So that's it. Simple interest, compound interest. So the first thing that you want to do, and what I forgot to do, was, is this a simple interest problem or is this a compound interest problem, right? Because if it's a simple interest problem, then you're going to use these formulas, and if it's compound interest, use the bottom formulas, right? So it just tells you which formulas to use, and also what you need on your timeline, right? For simple interest, we only need T on here. So T1 is 2 years, and T2 is 4 years. And the rate, I'll just put it over here in the corner, was 6% simple interest. What's a very reasonable way for this question to change? Well, I could make it a compound interest problem, right? Makes it a little bit longer, not harder, just a tiny bit longer, because you have to find the periodic interest rate and you have to find ends. But after that, it's all essentially the same, just different formulas, right? And so something like that. Of course, the amounts, the years could change, right? The question, or just hanging out? It's allowed. Right, and so that would be the most drastic change if I went from simple interest to compound interest. Ooh. All right. So, how about, I'll find the value of offer number 1 right now, and then we'll do a new timeline for offer number 2, work them separately. So here's our complete timeline for offer number 1. And so we need a present value. For simple interest, because you only have the one formula, it's been a while since simple interest, future value is P times 1 plus RT. because I don't give you all the formulas, I only give you the future value formula, you should technically show me how you got the formula for P before you use it. But am I going to notice? Probably not if you don't. As long as you use it correctly. So solving for P then, P is the future value over 1 plus RT. That's in general. So P1 is the future value of 1, which is 200,000 over 1 plus R, which is 0.06 times T, which is 2. Dreamy. .06 times 2 is 0.12. And so we get 200,000 divided by 1.12. Pulling a fast one, right? You got to do your 0.06 times 2 first and then do 1 plus 1. I think you'll find if you go 1 plus 0.06 and then times 2, it gives you the wrong answer because it's illegal math. So 200,000 divided by 1.12 is 178,571.4286, which in money is 178,571.43. P2 is also a future value over 1 plus RT, which we had the same future value, right? 200,000 divided by 1 plus R, which is still 0.06 times T, which is 4 for this one. So 0.06 times 4 plus 1 is 1.24. So 200,000 divided by 1.24 which is 161,290.3226, which in money is 161,290.32. Pardon? Oh, do you mean the total value? So no, so that's what we're trying to figure out, because 200,000 in 4 years from now is only actually worth 161,290 today. And so that's what we're dealing with, right? Overall today, if I bring all my payments to today, which one overall is worth more? So the total value of offer number 1 is, remember that 50,000 plus PV1 plus PV2, which is 50,000 plus, and I can't remember what it was. I'm going to cheat. Copy. I'll read it out though. Plus 178,571.43 plus 161,290.32. So then the total value, 50,000 plus 178,571.43 is 161. 290.32. 389,861.75. And that's already to 2 decimal places, so it's just in money. So that's the value of offer number 1 today. That's right. Yeah. So you can have a nap for 5 minutes. I'll wake you up when it's over, when we're on to the next question. Well, you can check your answers. So same thing, offer number 2. Offer number 2, exact same deal. We've got today, and that's still our focal date. And there was a payment of 450,000 in 3 years. Where did it go? Yeah, in 3 years. So, and a down payment of 25,000. It's nice because now we only have to do the 1 calculation, right? But this becomes present value 3, let's call it. 25,000 plus present value 3 is the total value of offer number 2 today. Well, simple interest, so time goes on the arrow, so we've got 3, and then the rate is still 0.06. Present value 3 is 450,000 divided by 1 plus 0.06 times 3. Divided by, 1.06 times 3. $1.18. 450,000 divided by 1.18. 381,355.9322, which in money is 381,355.93. So then the total value of offer number 2 is 25,000 plus present value 3, which is 25,000 plus 381,355.93. Oops, clean that up a bit. Plus 25,000, which is 406,355.93. Therefore, of course, offer number 2 is better because offer number 1 was 389,861. Right? Close, but not quite. Offer number 2 is better and worth 406,355.93 minus, what is it? 380.
389.
Thank you. Awesome. So subtract the one from the other, 406,355.93 minus 389,861.75. $16,494, $18 more. Cool. Okay. Any questions about that one? Okay. Let's do the next one then. You're saving for a trip to Mexico. Man, I love that place. And decide you need $3,000 in 3 years. Quite a trip. You decide to budget ahead by making 2 equal payments, one now and one in 2 years. Assuming an interest rate of 5% compounded weekly, now I'm more on the ball here because we need to figure out if we've got a simple interest or a compound interest problem. This is a compound interest problem, right? Because it's compounded weekly. In fact, let's make a note here. That means that F must be 12. What are your equal payments? So I'm telling you to use a focal date of 3 years and include a timeline. Okay. Yeah.
Why is it 12?
Just seeing if you're with me. Weekly is 52. Oopsie daisies. I should have said something like, and the most obvious thing in the world is that F is 12. I was like, how do I call her out on that? All right, thank you. So I'm telling you what to use as a focal date. And so you have to use that focal date. Right? And I'm going to tell you right now, a lot of your marks are going to be in your timeline, right? Usually what I can do is if you've got a good timeline and you've got the answer, well, you obviously did everything right. Even if you've got a good timeline and everything looks reasonable, even if you get the wrong answer, there's very few marks lost, right? Because you told me what you're doing and everything looks good. And as long as you've got a complete timeline, that's a lot of marks. Okay? And so we want to make sure that you really have good timelines. So let's map this out. So remember, for timelines that are a little bit trickier like this, right, we have to figure out how many ticks we've got on there, right? And so we need some amount in 3 years. We need $3,000 in 3 years. So that has to be on there. And I'm going to make a payment now and a payment in 2 years. Right. Looks like those are the only ticks I need. Yeah. Or is that a stretch? Oh, 52? The weekly, because there's 52 weeks in a year. And when we started chapter 5, right, I gave you a table of all the frequencies. And so that's how you know too. You have to memorize those. But most of them are pretty good. Okay. All right. So let's map this out. So here we are today. And in 3 years, we're going to be under the sun in the water. in Mexico. 3 years, man. All right. We need a tick at 2 years as well. And remember, I just put it, I don't have to put them kind of proportionately on the timeline, just making room for more ticks if I need them, that type of thing. And so I know at the 3-year mark, my total has to be $3,000 because that's what I need, right? And so I'm gonna make some unknown payment today. Remember, for unknown payment amounts, I just use X. And the same payment, so equal payments, so X today and then X in 2 years, and those are gonna grow to total $3,000 in 3 years. And so I can pull this forward to be some future value 1 plus some future value 2. And we know that these have to equal $3,000. We have to put N on each of these arrows. N1 is time times the frequency. The time between 2 and 3 years is 1 year. And the frequency is 52, so 1 times 52 is 52. And for N2, we've got time times the frequency. Time between today and 3 years is 3 times 52, which is 156. For a complete timeline, I also have to have the rate, the periodic interest rate in this case, right? Because we've got compound interest. And so down here, I'll just say I is R over F, which was 5%, so 0.05 divided by 52. 0.05 divided by 52 is 0.000961538. And I'm just going to make a note to myself that I'm going to store this in 1. Because I don't want to type that in again. Okay. Future values are nice. Right. Formulas. Nice and straightforward. So the future value is PB times 1 plus I to the power of N. Right, so everything on the screen here up until the question, that's a complete timeline. Right, so if you've got that and you've got your answer, even if it's off, well, you had the right idea. Right, that's worth a lot of marks. But there's a lot of components here, right? But they're always the same. Well, they always behave the same. So the future value 1 is PB, which is just X. Right, so this is one of those where we have to solve for X, but that's okay. Times 1 plus I, which was 0.000961538, to the power of N, which is 52. Value is X times, so you can use recall 1 if you stored it in 1, and then plus 1 to the power of 52, X times 1 point, and you know what? I'm going to write the coefficient out in front. 1.0512454842 times X. Future value 2 is x times 1 plus, I'll show you another way that you're allowed to do it. As long as you told me that you've stored it in 1, you can cheat and write recall 1. Dun-dun. To the power of 156. Right? But you have to have told me where you stored things. So 1 plus recall 1 to the power of 156. Writing it as the coefficient, I get 1.161750513x. Uh-oh. Do you see what my uh-oh was? I didn't store the coefficient of future value 1. I don't want to type it out, so I'm going to recalculate it. But I'll store this. I'll store this in 2. But for now, I'm going to store this in 3. Store in 3, and 1 plus recall 1 to the power of 52. Store in 2. Now they're all stored. Phew. Disaster. All right. So now we have these future values in terms of x, right? 1.05x and 1.16x has to equal $3,000. And so we need 3,000 equals future value 1 plus future value 2, which is, should I really cheat? Recall 2x plus recall 3x? No, not yet. I will though. 1.05 1245842x plus 1.161750513x is pulling out the common x, and then now I'll cheat and say recall 1 plus recall 2. Because recall 1 is this guy and recall 2 is this guy. Recall, oh, no one caught me. Come on. Recall 2 and recall 3. Come on. Recall 2 plus recall 3. I get 2.212996355x is 3,000. It's 3,000 all along there, but it doesn't come into play until now. So solving for x, I get x has to be 3,000 divided by 2.212996355. 3,000 divided by previous answer, 1,355.62808. So x must be $1,355.63. Right. Therefore, each payment must be $1,355.63. that's not 3,000 divided by 2, right? And that's because we could deposit the 1355.63 at an interest rate, at the same interest rate, and it'll grow to 3,000, right, at those 2 time points. Okay. So, any questions about that one? No, just keep going. Got it. All right. So, question 4. Let's see where this page break is. A contract requires payments of $5,000 and $7,000 made in 2 and 6 years respectively. So what 2 equal payments made today and 4 years from today are equal in value to the original contract? This is basically the same question that we just did, but a little bit harder, right? Because now instead of saying, okay, these 2 equal payments have to equal 3,000, now we have to figure out, well, what was our original payment value at that date, and what are our new values? They have to be the same, right? So it's basically the same. We've got compound interest, compounded bi-weekly. Let's see if I get this right. F is 26 for bi-weekly. I'd say that's the one that people struggle with the most. Bi-weekly is 26. Because you want to do, I don't know what you want to do, but anyways, it's 26. All right. So let's make a timeline. Okay. And so we did one of these last day, right, where we've got, okay, some original payment scheme, and then some new payment scheme, right, with the unknown payment amounts. Okay, so you could try to squeeze them on the same timeline, but what I'll do is I'll just kind of visualize one above the other, kind of like offer number 1 and offer number 2, but I'm not going to do calculations in between because I want to be able to look at them. So for the first contract, we said, okay, 2 and 6 years from today, presumably. So I'm going to have a tick for today, just to make sure that I've got a reference point. And then, oh, good. I'm going to make a payment today, and then 4 years from today. 2, 6 today, 4 years. So I've got 4 ticks, right? Yeah. So here we go. Start today. And 2, 4, 2 years, 4 years, and 6 years. When we're doing these, what we found last day was it's actually easier if we just have all the ticks on one timeline, and then the ones that we use, right, the other ones we can fill in, but the other ones we can just ignore, right? So the original contract, original contract was 5,000 2 years from now and 7,000 6 years from now. I've told you to use a focal date of 4 years from today, right? So this is our focal date. That means all our payments have to be drawn to 4 years from today. So it doesn't matter which one we do first here. I'm going to do the 5,000 becomes a future value 1. 7,000 becomes some present value too. Adding those two up, I get the total value of the original contract. Total value of original contract. I'm going to put n on each of these arrows, right? N is time times the frequency. Time between 2 years and 4 years is 2 years. Uh-oh. 2 times 26 is 52. Oops. Same thing here for N2, let's call it. Between 4 years and 6 years, I've got 2 years times 26, which is 52. Makes it glitchy, but I don't know why. Okay. So, bless you. Last thing we have to put on this original contract timeline is the periodic interest rate, right? I is R over F. R is 0.03 divided by 26. 0.03 divided by 26 is 0.001153846. And I'm going to store this in 1. See, this is what it does when I plug it in. All right. So the total value of the original contract obviously has to be the total value of the new contract at 4 years, right? Same time point. So now we can do the same thing for the new contract. I'll even have the same time points. Today, 2 years. You don't have to, but it's nice to show 4 years and 6 years. So the new contract was 2 equal payments. So one made today and 4 years from today, right? So again, these unknown payments we denote by X. So X today and X in 4 years from today. 4 years is still our focal date. Which means that we're going to pull the X from today and make a future value. Oops. Let's call it future value 3. And the total here is going to be, so if we add X and future value 3, that's going to be the total value of the new contract. We have to put N on this arrow, so N is time times the frequency. Time between today and 4 years is 4 years, and the frequency is still 26. So we got 104. I'm just going to make a note here that I is 0.00, because I already calculated it, but it's nice to have it on each timeline. 0.001153846. And I'll just make a note here that that's stored in 1. So we know that in order for these two to be equivalent, right, the total value of the original has to equal the total value of the new. Right? So in order to be equivalent, right, the total value original has to equal the total value new. So I'm going to find these future values, present values, add them up, solve for x. Easy. No, it's a lot of work, right? Well, once you've kind of, once you see the pattern, it's better. So let's start with future value 1. Future value 1 is PV times 1 plus I to the n, which was 5,000 and n is 52. 5,000 times 1 plus, do I write it out or do I write recall 1? Recall 1. I know. I don't want to confuse people. We will do that later where I'll get lazy and I'll just write recall 1, recall 1. But I don't know. You can. I'll write the long way. And n was 52. Okay. So we have 1 plus recall 1 to the power of 52 times 5,000. Yes, I'm going to do it all in one go. 5,308.999098, which in money is 530 or 5,309. Let's think about that one. 999. Present value 2 is, and this one's on your formula sheet, right? The future value over 1 plus I to the n. So you've got the future value is 7,000 and n is 52. So 7,000 divided by 1 plus, over here, I'm going to write recall 1 if you want. 0.001153846, or recall 1 if you prefer, to the power of 52. 1 plus recall 1 to the power of 52, and then 7,000 divided by that. I get 6,592.57976. In money, we get 6,592.58. I'm going to go ahead and just calculate future value 3 as well, and then I'll combine them, right, and solve for x. So future value 3 is x times 1 plus 0.001153846 to the power of, what was our n? 104? Yes. 1 plus recall 1 to the power of 104. So we have 1.127418857x. I'm going to store this in 2. So now we've got the original value has to equal the new value. The original value was future value 1 plus present value 2, which has to equal x plus future value 3, right? And this is just from looking at your timeline, right? The total value, future value 1 plus present value 2 has to equal x plus future value 3. Right? And that's how we're going to solve for x. So we've got future value 1, 5,309 even, plus present value 2, which is that 6,592.58, which is x plus 1.12741887x. $5,309 plus 6,592.58. 11,901.58. And then plus 2.127418857 times x, not plus, but equals. So x is 11,901.58 divided by 2.127418857. So divided by 1 plus recall 1. Recall 2. 1 plus recall 2. Yeah. And then 1 over that. 11,901.58. No, I might have bunged it up. So make sure you get the same answer. And if you don't, let me know. 5,594.375533. Because I'm solving for x. So I have to move the 2.12 over to the other side. But then I like to have x on the left, so I revolved it. Smooth move, right? I know it's tricky. Well, because to solve for x, right, you'd have to divide both sides by the 2.12. And so you'd have to do 11,901 divided by 2.1274. And that's your x. And then
I'm just.
Oh, here you go.
I think I'm just.
Oh, I see where I actually skipped a step. I'll make some room here. 11,901.58 is x times 1 plus 1.1274. I added a step here. This one, Mac. I added that one. Because I just went straight to the 2.12, but I pulled out a common x from here and here, and then I get x times 1 plus 1.12. We can come back to it later.
Just show you how I do it.
Cool. Is that what you guys got? Because like I said, I feel like I fumbled on my calculator, but I really don't want to do it again. Good? I know you guys are counting on me. Fine, I'll do it again. All right, recall 2. That's the 1 plus 1. 1 over x times 11,901.58.
So why do you add an extra 1?
Because I pulled out, so it's x plus 1.12x. Right. Yeah, so I'm pulling out a common x, but x just becomes 1, right? Because if I multiply that x back in, I have to have x times 1 to get to x. Right, so you want to be careful that you take that x. So in money, we have $5,594.38. Any questions about that one? No?
It said it had to be 2 payments, didn't it?
But we've taken that into account because we said x plus future value 3, and future value 3 was the first unknown payment, right? And so that's why we have to have the x in there. So each payment is $5,594.38.
I just did it.
All right. Last long answer. What is the value 3 years from now of the following payment stream using an 8% weekly compounded rate of interest? So we've got weekly compounded, so we've got compound interest again. Ugh, that's all right. There's more we can do with it, I feel like. So weekly compounding, so F, keep me honest here, 52. So we want to know what's the value 3 years from now. If you have a payment 1 year from today of 17,000 and a payment 4.5 years from today of 14,000. And then there's a note saying all calculations must be done without the help of the time value money features of your financial calculator. Here's the thing, for some of these problems, let's see, not the unknown payment problems, which we have a lot of, right? But for this original contract, for example, you could have used your calculator to find the future value and the present value, right? As long as you list all your calculator entries, then you're safe. But I encourage you to do everything by hand for this test, right? But if you really, really like using your calculator, then just make sure that you're listing what all your entries are, right? And that's how you show your work. Okay. But I think that you should be able to do all of this test by hand. Use your calculator to check your work. So here I'm forcing you to do it by hand. What's the value 3 years from now? Okay, so we've got from now, so we need today, and then 3 years from today. We've got a payment a year from today and a payment 4.5 years from today. So that's 4 time points that I'm counting. And so for my timeline, it's because it's plugged in. It does this glitchy thing. 2, 3, 4. So I'll start today, and then 1 year from today, and then 3 years from today, and then 4.5 years from today. This one always trips people up on the Moodle quiz, right? Because what's the value a year from now? If I ask you what is the value at this point, that is your focal date, right? And so what's the value 3 years from now? Well, 3 years from now is your focal date, right? So it's implied, which means all our payments have to be drawn to the 3 years mark, even though there's no payment there, right? So we've got a payment 1 year from today of 17,000 and a payment 4.5 years from today of 14,000. And I want to know what's the value 3 years from today. And so I have to pull this guy forward. Come on. Future value 1. The 4.5 year payment gets pulled back, so it's a present value 2. And then the total, so if we sum these up, this is the total value 3 years from today. Now this is compound interest. So on our arrows, we have time times the frequency. Time between 1 year and 3 years is 2 years, and a frequency of 52. So we've got 104. Just checking. And 2 must be time times the frequency. Time between 3 years and 4.5 years is 1.5 times 52. 1.5 times 52 is 78. The last thing we have to do is the periodic interest rate, which is I is R over F. The interest rate is 0.08 divided by 52. 0.08 divided by 52 is 0.001538462, which I will store in 1. This is easier than what we did earlier, right? This is basically the original payment scheme from the question we just did, right? Without that added part of unknown payments and things, right? And so you can think of question 3 as like a big monster child of question 2 and 4, right? They're the same, they're doing the same stuff. Okay. So we've got future value 1 is the present value times 1 plus I to the power of n. The present value is 17,000 times 1 plus 0.001538462 to the power of n, which is 104. To the power of 104. Times 17,000. So I get 19,947.23213. So future value 1 in money is 19,947.23.
Should you keep all the numbers still?
No, so for the values, you round to dollar amounts.
Just for.
So just for dollar amounts, yeah. So all your interest rates and things like that, you keep all your decimal places, but for the future values, present values, those get rounded to dollars before you add them up. So present value 2 is the future value over 1 plus I to the power of n, which is 14,000 was the future value, over 1 plus I, which was 0.001538,462, to the power of n, which is 78. One plus recall 1 over that times 14,000. The present value 2 is 13,978.49462. So in money, present value 2 is 13,978.49. So then the total value 3 years from now Hey, make sure you grab candies before you go. So the total value 3 years from now is future value 1 plus present value 2, which is 19,947.23 plus 13,978.49. 19,947.23 plus 13,978.49. I get $33,925.72. Is that what you guys got? I'll take that as a yes. Any questions about that? No? Let's get out of here. No?
That's wrong.
It's wrong. Uh-oh. Ah! Stay tuned. Did I enter the 19,947.23 plus 13,978.49? I'm still getting the same one.
Maybe I'm wrong.
Could be something. All right. Yeah. Oh, it's different? Uh-oh. So this one? Okay. What did I do wrong? 1 plus recall 1 to the power of 78, and then 14,000 divided by that guy. I get 12,004.
Yeah.
Is that what you get? I did it wrong, guys. This one's wrong. This one's wrong.
What did you end up doing?
I don't know. Slip of the wrist. I'll do it again. 1 plus recall 1, all to the power of 78. Maybe I used a different, maybe I used the wrong power or something. that seems likely.
You use 100.
Yeah, something like that, right? And then 14,000 divided by that guy. Yeah, I'm still getting the 12,418.03117. 12,418.03, which changes this little guy and this little guy. 12,418.03. 19947.23 plus 12,418.03. 32,365.26. Better? All right. So make sure you do assignment 6 and 7 for Tuesday. They're due Tuesday night, right? But they're going to be good practice for the test. And yeah, test next day. Let's do this. See you guys then. And make sure you grab candies on your way out here.
I did this wrong.
Let's see. I'll just end this recording before. Otherwise, I'll forget.